All right, number 33, they're asking us to take the derivative with respect to x of a definite integral with x's as both limits of integration of tangent of t dt. So hopefully we recognize what this is, guys. A derivative of a definite integral. This is an FTC Part 2 problem. However, the only issue is that formula only works when the lower limit of integration is a constant and the upper limit is some function of x. So how are we going to do that? We're going to break this integral up into two different ones. So this is going to be, let's write this here, the derivative with respect to x of, and I think I'm going to start a big bracket now, the first integral is still going to start at the square root of x, but then it's going to end at some arbitrary constant value called a. The integrand stays the same, tangent of t dt. We'll add to that now a second integral that starts where the first one let off at a and then goes up to this value here of x squared of tangent of t dt. All right, so we've used the additivity property to create two different integrals now that add up to the original. And now, hate to say this, but we're kind of distributing this derivative inside there. Or better yet, I will in just a second. The problem now is that this integral, we've got things in the wrong order. We need that constant on the bottom. So let me take one more time to write a derivative of, and in brackets, this first integral, we need to take the opposite of the integral from a on the bottom now to the square root of x on top of tangent of t dt. And the second one already had the constant right where we wanted it down on the bottom. So the integral from a to x squared of tangent t dt. And now I think I'm ready to go ahead and distribute that derivative in there if you want to look at it that way. Now there's still a negative right here, so we're going to have an opposite, but the derivative and the integral cancel each other out. It becomes the tangent of that t gets replaced by the upper limit, tangent of the square root of x, but now times the derivative of that upper limit. And the derivative of x is 1 over 2 root x. So I'm going to make that a 1 over, there you go, 2 root x, and then I'll rewrite that negative out in front there. Got it. And the second part then plus the derivative of this integral. So we rewrite the integrand, tangent. We replace the t with the upper limit of integration, which is x squared, and then multiply by the derivative of that exponent, which is a 2x. So that is what we have there, everybody, and I really don't think in looking at that expression can be simplified at all. So let me check what their solution was here to problem number 33 in 5.5, but I think we have this one right. So they have, here we go, they've got, let's see, 2x tangent squared. Yeah, they started with that term right there, and then a minus tangent of root x over 2 root x. They just combined this into one fraction there. So yeah, we've got the right answer here for problem 33.